Thank you, Cornel, for the introduction and for the chance to say something here. Indeed, at S&T, I work on projects to develop new applications for satellite data, and today I get the honor to present Silvisense, which was a product line developed actually by our Norwegian office. So I have to give them the credits for the work that I get to present. So Silvisense is a line of products that is aimed at forest owners and is aimed at automatically monitoring the state of forest and automatically detect and track changes in that area, like clear cuts, disease outbreak, forest fires, altered land use, or anything that is of interest of forest managers that may need further investigation or things like that. Given the time, I will not go into details of how it works. That would be I think a topic all by itself. But there's essentially 3 steps to how Silvisense works. Of course, it starts all with the satellite data that needs to be pre-processed. It needs to be corrected geometrically. It needs to be aligned, etc. And then it goes to the next step, which is really the core of Silvisense, which is a number of machine learning algorithms where a couple of main things take place. One is cloud masking. We've developed quite a sophisticated cloud masking technology to really make the most out of the data that is available. Various classification algorithms to really look at what can you see in these forests. And of course, based on that, automatic change detection. The last step, probably the most important one, is verification and validation. We spent a lot of time validating the results of these algorithms to make sure that what they predict is actually correct, and then use these results to further improve the algorithms to really boost the reliability of the algorithms. So that's as far as I go with the technical details. I thought it would be better to just show examples, because I think that speaks much more to the imagination than flowcharts or equations. So as I said, an important part is the cloud masking. You can imagine forests tend to grow in places where there is precipitation, so there will always be clouds in the images, and they can influence the information in the individual pixels. So what we've developed is a method to determine, not in a binary fashion, whether there is a cloud or not, but per pixel, we look at what percentage of that pixel is covered by clouds. And that way, we can really optimally combine data through time by looking at how much percentage of the image is influenced by clouds. So to what extent can you still use information in that pixel, and how can you best combine them? So this is a very important step to improve the reliability of the data. Then the basis for everything is a land cover classification. So here you see 2 images, a Sentinel-2 image on the left, and then on the right, that image is classified in various classes. Each of these will have, again, subclasses, but it's not important. And essentially, this allows you to make a distinction between urban regions, or let's say transport infrastructure, and things like areas with vegetation, water, or bare soil. So the things that really matter when you are talking about the context of forestry. Once you have done this, that's when you can do the interesting things. The obvious thing to do, of course, is look at changes in this classification. So this is an example of the detection of clear cuts. Essentially, you look at, were there trees before and not after? Is that change consistent over time, or is it perhaps caused by an artifact in the image? So we really look at the time series on that. And based on that, you can make these let's say, confidence intervals that you see here. So the various outlines are levels of confidence that there was a clear cut. And this was also validated, and this method can predict with a very high accuracy. I think it was about up to 80% of the cases. This is an actual clear cut. So this way, you have a fully automatic way to detect whether in a forest area you have clear cut. So this is very good input for inspection, for instance, of forests. More advanced application we're working on in Portugal is actually to not look at just is there forest or not, but what is the state of the forest. And in this case, the project focused on diseases, the pinewood nematode, that has a very specific effect on the development of the tree, and that translates into a very specific effect on essentially the color of the tree. So the response in the color of the pixel of the forest. And so again, using a neural network, you can train that to pick up these changes, and then you can make these maps where you have sort of a probability of disease outbreak. And that can again be input for follow-up monitoring, for instance, by dispatching drones to look at greater detail or on-site inspections. And of course, in the process, you get all kinds of interesting side products. You get, of course, again, maps of where there is forest and where there's not, but also other properties like we're looking into also fire damage to forest, because that also has a very clear signature, of course, in what the forest looked like. So very nice follow-up, let's say, more advanced way of processing the data. Another sort of byproduct of all this is, since we have all these time series of data, we have all the information on the data quality of each pixel through in each time interval, we can also make what we call Geo Mosaics. And essentially what you can do is say you want a map of Norway in summer, then we define an interval of those months. We check which are all the data tiles that are available, and then using this information on the data quality, on the cloud cover, etc., we sort of combine it to the best possible mosaic, which can then be input for other products, other services, scientific studies. So you really get very high quality maps with that. Here's an example, and on the right, the various colors is all the different maps and parts of maps that were used to create the image on the left. So it's sort of a necessity for us to create this to do our service, but of course in itself is a very nice nice product to use. And then lastly, not quite satellite data. You can of course do the same thing also with aerial photography. And the advantage there is a much better resolution. This example is 20 centimeter resolution, which of course is an incredible increase with respect to satellite data. And because of that, you can also go further than that. So you cannot only say is there forest or not, but we can say what type of tree species it is and the growth stage that it is. So it allows very granular insight into the forest and has, again, many applications from forest management, monitoring how natural areas recover after disasters, all kinds of things. So it allows very detailed study of forests. So yeah, these are just a number of examples of what we can do with our Silvisense technology. It's not a product that spits out one thing. It really is a technology that can be applied in many use cases. So very happy to hear if this triggered any ideas. And if so, feel free to contact me or any of the people that are listed here. And thank you for your attention.